Okay, so in the previous lab, we had looked into shifting of left operation. Okay, so we looked into shift left operation, and as we know that it was multiplied with 2, just like how we know the bit values, right, in your digital electronics. So the same concept, and we also had seen reverse subtraction, right, and we had seen the addition of first in numbers, right. So today we will continue our learning with the programs, and first we will start off with swapping of the contents of register. Now for swapping, the major thing that we will be doing here is XOR operation, right? So as usual, we will be giving the data here. Okay, we'll be declaring area and then entry export. Fine. So R0 is given with a value, right? And R1 is also given with a value. So our aim here is whatever data is given in R1, that should be getting into R0, and whatever is in R0 should get into R1. So for this, what we are doing is we are doing the XOR operation. Now, as we all know, in XOR operation, if the values are same, then it's going to be 0, and if the values are different, then it's going to be high, right? So taking this property into consideration, right, we will swap the data. Now you can see here in the result, okay, R1 has the value of R0, right, 0xF6310246, right? So this value of R0 has been transferred to R1, and R1's value will be transferred to R0. So this is the aim here. So before we understand this, okay, let us understand how this exactly works. Are you all able to see the screen here?
Yes,
Are you
sir.
all able to see the notes? Yeah, fine. So what we will do is, we will just take some data. Okay, R0 is 62 and R1 is 34, and all this is in hex values. Fine. So we're going to do 3 times XOR operation. So R0 I have taken here 6, 2, and R1 is 3, 4, right? So this is taken. So I'm doing an XOR operation here. Same 0, different 1, same 0, right? So the XOR operation of R0 and R1 is done, and this is the value that I get, right? Okay. So once I get this value, right, so this is my new value now, R0 and R1, and this is sitting in R0. So remember, R0 has an updated value now. It doesn't have 62, but then it has 0, 1, 0, 1, 0, 1, 1, 0. So this is the new value for R0. Now again, what I'm going to do is with this updated value, I have to XOR with R1. So R1 is already here, 34, right? 34. And I'm going to take this new value, right? So this new value I'm going to take, and I'm going to do an XOR operation, right? And this one should be sitting in R1. So which means now the value of R1 is getting updated. So R1 will have 0110 0010, right? Okay. Now again, as you all know, R0 has this value and R1 has this value. So I'm taking those values down here, right? So this value, just a moment. Yeah. So this value I'll be taking here down, and R1 value I'll be taking here down. So again, I'll be doing an XOR operation, and the value should be sitting in R0, right? R1, R0, and the value should be sitting in R0. So as we finish the first, second, and the third iteration of XOR, okay, we should be able to see that R0 finally has 0, 0, 1, 1, and 0, 1, 0, 0. So this is actually the value of R1, right? 3, 4. And yeah, so now we will get back to the program, okay, and we will see, and here you can see, right, your R1 has this value, isn't it, which is 62, So which means these datas are swapped with each other. Any doubts here, students?
No, sir.
Fine. So this is how you will get this program executed, and you can load any value for that matter, right? And you can check as to how these values are swapped between each other. So I hope this concept is clear with this simple program, isn't it? Yes. Can I proceed?
Yes, sir.
Thank
Yes,
you.
sir.
Thank you. So the next one that we'll be looking into, and also have a habit of writing an algorithm, right? Where you initialize the code and link the program to the processor, load the values into R0 and R1, then XORing operation. So instead of writing in statements like this, right, it is better that you put it in flowchart form. And just before your examinations or tests or whatever for that matter, you can just look into the flowchart, and immediately you'll get to know that you have to use an XOR operation here, and from where to where you have to transfer, right? So that will give you a clear idea. Right. So moving on to the next one, which is actually the next program. Yeah, the factorial of a number, right? So when we talk of the factorial of a number, we let's take for example, if I say factorial 10, then how do I do it? 10 into 9 into 876, right? To 1. So this is the way that we normally calculate. So for that, we have a program here which helps us in calculating the factorial. So the initial codes are given as usual, and then we are using 10 here. Okay, so this is the number whose factorial is to be determined. So if I say calculate the value of 30, then you'll have to replace this 10 with 30, and the starting number, okay, the starting number of this factorial. So ultimately I will be using this R6, I'll be using R7, and then I'll be comparing if this 10 has been reduced, because what I do is from 10 I go to 9 and then 7, 8, 7, 6, 5, 4. So like that I go, and then it compares. Okay, this code actually compares and checks if it is going to 0, right? So what is happening here? It is multiplying the contents of R6 and R7. So here it will be 10 into 1. Okay, so 10 into 1. So the result will be in R7. The final result will be in R7. So this happens only if R6 is greater than R7. So what I do after the next multiplication, next I will try to reduce the count from R6. So 10 becomes 9 in this step, right? So this will keep going on till it becomes 0. So once it becomes 0, then the loop is broken. The loop is broken and it stops the execution. So you should be able to get this value, and of course this is in hex. So if you calculate it 10 into 9 into 8, you'll be getting a decimal value, and then you'll have to convert that into hex. Can someone tell me how much is it for factorial 10 and verify if this value is correct in hex? You can use your calculators. Yes, can we quickly do that? Is someone doing it? Can I have some responses? So you will be getting like 3628800, So that's the value that you're going to get. And once you convert, okay, to hex, you'll be getting 375F00. Right? So that's the value that you'll be getting.
Yes, sir, it's correct.
It's correct, no? Yeah, thank you.
Yes.
So I think now you have understood, right? So we are moving a value to a register R6, and then we have starting number, okay, from which it has to, the lowest number, and then it is comparing with 0. Okay, it is just checking if this 10 is going to 0 or not, and then R6 and R7 is multiplied 10 into 1. Okay, so this happens only if R6 is greater. Okay, R6 is greater, which means this value, it will be comparing if it is greater than 0. Then it will be subtracting if 10 is greater than 1. Yes, it is greater than 1. So multiply if greater, and then it will subtract if greater. R6 is reduced. So why is this term used if greater, if not greater? Because it, at a point, you will be finding that this value will keep on reducing, right? And then you are multiplying both R6 and R7, right? So you're keep on moving here 1 to R7. So R7 also keeps on increasing, and R6 also keeps on increasing. So this is how it actually works. So any doubts here, students? When you execute it, you'll be able to
No,
understand.
sir.
Yeah.
Okay, sir.
I will show you how it is done. So the next one, we'll be looking into is a new program, which is the data transfer. That's also making use of various instructions. Okay. Able to see this window?
Yes, sir.
Yes, sir.
Yeah, fine. So this is another way of moving data from one register to another register. See, ultimately you should understand exploring the possibilities of uh, coding is done only when you know the instruction set. Okay, so if you know how to play around with these instructions, then it becomes very easy for you to communicate between one register to another register, or pass data from one point to another point. So this is one such program, an interesting program, where we are making use of flags. I think all of you know what is a flag, right? We have zero flag, carry flag, negative flag, right? So all these are very much necessary when we talk about parity, when we talk about overflow. So all these, right? So this program actually explores the contents of flags. So we are doing the initial coding, right? We are initializing, and then we are sending 0. Okay, 0 is moved to R1, and we are moving 5 to R2, right? The number 5, and then we are moving 4 to R3. So we are using R0, R1, R2, R3. So only with these registers we are utilizing and transferring the data. So 0 in R1, 5 in R2, 4 in R3, and value of R1 is moved to R0 if and only if. Okay, if and only if you can find move S here. Okay, move S. So what happens while moving from R1 to R0? So R1 now we have 0, and so if this 0, okay, so R1 has a value 0, so 0 is moved to R0. So value in R1 is copied to R0. And also what it does is it has move S. It's not only move, but move S. So it alters the flag. Okay, so since we are moving a 0 to R0, okay, so 0 flag will be enabled. Okay, so it is like showing that we are transferring 0 to a register. So along with transferring 0 to a register, we are enabling the 0 flag. right? So 2-in-1 is happening here with this instruction move S. Now there's another interesting instruction here called move EQ. Okay, now this will actually check. Okay, this will check if the value in the 0 flag is set. Okay, if then only the value will be transferred from R2 to R0. Okay, so if the flag is set, okay, so that is important. So if the flag suppose is not set, okay, if we try to move some other value when the flag is not set, then this instruction will not happen. So ultimately this instruction will enable 0 flag to be 1 and move EQ. Okay, move if equal to, right? Move if equal to, so it's checking for the 0 flag. If it is set or not, then only the data of R2 will be transferred to R0. So which means R0 right now, it has 0. So 0 will be rewritten with the new value 5 only if the 0 flag is set. Able to understand, right? Students, able to understand?
Yes, sir.
Yeah. So move if equal, right? So next again, what we will do is we will use the same instruction here, move S. Okay, we are moving 0 to R3. So move 0 to R3 and it also sets the 0 flag. So whenever you are seeing this S, okay, along with move, so that means we are actually changing, or we are trying to update the value in 0 flag. Okay, so again the same process here. Okay, R3 is 0 and then it is getting moved to R0, which actually had the updated value 5. Okay, so this will check, okay, if the flag is set or not, then only R3's value will be moved to R0. So ultimately I am again making R0 as 0. Next, there is another instruction here called the negation. Whatever R2 has value, right? So that can be negated. So here we have R2 as 5, right? We have never changed the value of R2. So this can be negated. Okay, this can be negated and the value is again updated in R2. So you will be able to understand that when we do a step-by-step execution. Right? So 3 different kinds of instructions: MVN, move EQ, and move S. So these are the 3 major important instructions. Move S alters the value of flag, move EQ checks the value of flag and then transfers. If not, then this transfer will not happen. R3 to R0 will not happen if the flag is not set. Okay, the flag is having the value of 0, then the value of R3 will not be moved to R0. Similarly, the negation is going to happen. Okay, so now let us shift our focus to the execution part. Right. You're able to see this software, right?
Yes, sir.
Yeah. So first we will look into XOR, the swapping of data. And one more thing, keep in mind, you should have only one file here. Okay, startup and the other working file. If you have multiple files, you will start getting errors. Okay, so I have the swap file here and here it's added. So I'll just save. I think by now all of you know the steps, isn't it? Translate, build, check for errors. Okay, I have 0 errors, that's fine. And then Next, I can go into debug mode. You get a small information that it's going to have 32K. And you have different options here, right? You can either run step by step. Okay, so I'll be using this step by step so that you'll be able to understand. So first, the values are yeah. So you can see the values here, okay, towards your left hand side, how the values are changing. So R0 is now given the value F6, okay. Then R1 is given the value 175. Okay, now the XOR operation is happening. XOR operation, and the values are getting updated, right? So now if you can see, here you have 17, okay, and that is for R1, but then it has gone to R0. Okay, similarly, F6 was in R0, but then here you have it at R1. So the values are interchanged. So next we'll look into factorial. At any point, any doubt, please let me know. Okay. Okay. Zero errors, fine. Build it. Zero errors, fine. Okay. So where are we going to have the final value? Students, where is the final value going to sit? Our final result is going to be in which register? Yes, any response?
R6.
Sure, R6. So we are going to have, yes, R7 is correct, Kuldeep. So we are going to have the final value in R7, right? So I was telling you, 375 F double O. So R6 is going to have a different value because it is comparing, right? So hope there's no doubt here. Is it? Any doubts here, students?
No, sir.
Okay. Now you can also try, okay? You can just make sure that it is not 0. Maybe you change the value here, okay? You change the value, and then the 0 flag, of course, is not going to get set. So the value of R1, or move equal, yeah. So R2 should not be moved to R1. So you can also make those modifications in the program and keep checking, right? Okay, zero errors. Fine, we have built and transferred. Get into debug mode. And do a step-by-step execution. So you can see that, R2 is given the value 5 and R1. Okay, R1 has the value 0. Okay, and similarly R3 is having the value 4 here, right? All these are getting updated live, and now it's checking for equality, right? Move if equal, checking for equality, and then if it's equal, then R2's value should be moved to R0. R2's value, yes, it was equal, so it has moved to R0. Good. And the next one is 0 moving to R3. Yes, because in the previous one we have checked for the flag, right? We checked, and here it's going to change the value of the flag. Okay, fine. And then we are going to have the negated value of R2, and the value is, so you can see, right, 5, and it is been minused with the highest value, right? So we are going to get f. Okay, right. So I think now you have understood as to how this program works. You can even try giving some other values and checking if those are transferring or not. So the reason that we have included this program is because so that you can explore move EQ, move S, and MBN. Okay, so I hope you all have understood this program. Any doubts, students? Ma'am, Dalia ma'am, you want to add anything? Okay. So you can start executing. Okay, and please post it in the classroom. Okay, so that we can have the grading done for them.